Hi there, it's Mrs. Tremblay. We learned how to add integers. Now it is time to learn how to subtract them. What's kind of nice is you're going to see how adding and subtracting integers are related, and you'll be able to tie these little rules together by the end of the lesson. So it's kind of nice. All right, we're going to start off with just some basic problems here and using the number line as a model, because we've been learning this unit that number lines really are very helpful. So, yeah, you might be thinking, Mrs. Tremblay, come on, 8 minus 5. I know what 8 minus 5 is. I just chose one that you'd already know the answer to, so you can get used to using the number line model. So when you have subtraction, you're not combining these together. We're saying this is where you start, and this is what we're taking away. So if I look at the number line, if my starting point is 8, here's 8. If I'm subtracting 5, taking 5 away means I'm moving 5 to the left, correct? So here's 8, I'm going to take 5 away, so that means 1, 2, 3, 4, 5, I end at 3. Now, 5 minus 8 is not 3. This order does matter when you subtract. There's no commutative property for subtraction. So if I'm taking 5 minus 8, 5 is where I'm going to start. You can't change what you start with, so I can't flip those around. Here's my 5. If I want to take 8 away from that, that means move 8 to the left. 1, 2, 3, 4, 5, 6, 7, 8. You'd end at a negative 3. So 8 minus 5 is 3, but if you have 5 and you try to take 8 away from 5, you're going to end up in the negatives. If you're trying to take away more than what you start with, that's what happens. That's what happens if you spend more than you start with too. So please be careful. When they send you those credit card applications in the mail, just don't do it. All right, negative 6 minus 2. Negative 6 tells me where to start. Here's negative 6 right here. If I want to take 2 away, that means move 2 to the left, 1, 2. So negative 6 minus 2 is negative 8. Keep going. Negative 4 minus 3. Here's negative 4. If I want to take 3 away, that means 3 left, 1, 2, 3. That gives me negative 7. And now these are a little bit different because I'm subtracting a negative. When you subtracted a positive value, you moved to the left. In all of those, we had our starting point and then we moved to the left. If you're subtracting a negative value, guess what direction you have to move? Negatives and positives are opposites, right? So you have to move to the right. So if you start at a negative 1, because that's where you're supposed to start, and we take negative 1 away, taking away a negative means move to the right 1. So I'd end up at 0. And that makes sense, doesn't it? If you subtract a number from itself, aren't you left with nothing? Yes, makes perfect sense. All right, 3 minus negative 2. The 3 tells me where to start. And if I'm taking away a negative 2, that means move to the right 2. So 3 minus negative 2 is actually 5. Now, in looking at these, you could probably come up with several different rules depending on if the first digit's greater or if it's lower than the second or about the signs. And you'd have to come up with tons and tons of rules here. And I'm not saying that you're not capable of that. I think you're very capable of it. But I'd like things to be easier for you. So there's one thing that we can do that will allow us to just use the set of rules we already have, and it's one set of rules, which is awesome. And it's this idea of subtracting integers by adding the opposite. So what we're going to do is we're going to change our subtraction problems to addition problems, and then we get to use those addition rules that we already learned. We already know them from section 1, 2. Same signs, add the digits normally, keep the sign. 2 different signs, subtract the digits, take the sign of the greater. So how do you make a subtraction problem an addition problem? You're going to use a method called keep, change, change. All you do is you leave the starting number alone, you change the subtraction sign to an addition sign, and you change the sign of the number that follows the subtraction sign. And what you have is an addition problem with the same value as the subtraction problem. So you're not changing the value of the problem, you're changing what it looks like to make it easier to work with. Once you've done that, you just follow the addition rules to find the sum. So just to kind of show you how this works, I'm going to scooch up here. I'm going to show you with these problems we already solved using the number line, how to keep, change, change. So keep, change, change. You only do this for subtraction, right? We didn't change anything for addition. So for subtraction problems, keep, change, change means keep the first number the same, change subtraction to addition, change the sign of the number that follows the subtraction sign. So this was a positive 5, make it a negative 5. And you just learned that when you add opposite signs, you subtract the digits, 8 minus 5 is 3, and you take the sign of the greater digit, which in this case is positive. Same thing here. If we did keep, change, it would keep the 5, change subtraction to addition, that was a positive 8, make it a negative 8. Two different signs, subtract the digits, 8 minus 5 is 3, take the sign of the greater digit, it's negative. Let's try it with one of these negative ones. So keep, change, keep the negative 1, change subtraction to addition, change the sign of the number that follows. That was a negative 1, we're going to make it a positive 1. And you learn when you add opposites, you get 0. Let's try one more like that. Keep, change. That was a negative 2, so we made it a positive 2. 3 plus 2 is 5. So you can see that this works, right? I'm not just making it up. That would be terrible. So let's practice with a few of these problems here where we don't have the answer in front of us. Again, I would recommend that you pause it, try it on your own, and then press play and see if you're right. Welcome back. The first thing we're going to do is rewrite these problems. Yes, you should rewrite them. When you get 100% on 3 subtraction quizzes, you cannot rewrite them anymore. Sound like a fair deal? Okay. So keep, change. That means my new problem would be keep the 3, change subtraction to addition. That was a positive 12, make it a negative 12. So now I'm adding 2 unlike signs. That means subtract the digits, take the sign of the greater. So 3 minus 12 is negative 9. Next one, keep, change. This time this negative 13 becomes a positive 13. I have to subtract the digits because I have 2 different signs. So 13 minus 8 is 5. And then the positive is greater, so it's a positive 5. Next one, 3 minus 3. Now some of you may have just said, that's 0. Or some of you are just in the habit of keep, change already. You can still do that. 3 plus, the sign of this is going to change, negative 3. When you add opposites, yes, you get 0. If you didn't change the signs of that one, I'd be okay, because we know 3 minus 3. It's okay. All right, next one, keep the negative 14, change subtraction to addition, change that positive 9 to a negative 9. So this time I have 2 of the same sign. That means add the digits, 14 plus 9 be 23. And I'm going to keep the sign. They were both negative, so my answer is negative. 0 minus negative 8. Keep the 0. Change subtraction to addition. Change the negative 8 to a positive 8. 0 plus 8, that's 8. Nothing has changed about that. And the last one on this side of the sheet, negative 12 minus negative 12. Some of you know that's 0 because if you subtract any number from itself, it's 0. Or if you wanted to keep, change it. Negative 12, change subtraction to addition. Change that negative 12 to a positive 12, and we see, oh, we're adding opposites. They're additive inverses. You got nothing. Okay, so basically all you need to do when you have a subtraction problem is keep, change it to make it an addition problem and use those rules that you already know. Sometimes you have more than 2 numbers to subtract though. So turn your page and let's talk about that. So subtracting more than 2 integers. Again, steps are very similar here. We're going to change it to addition. You leave the first number alone, and after that you add the opposite from left to right to make the entire problem addition. You only change the signs of the digits that directly follow the subtraction signs that you changed. And then we'll use our addition rules and those properties, commutative and associative. We can use them once you make your problem addition. You can't use them before that though, because there's not commutative of subtraction. We already said that. Okay, so take a look at this first problem here. There's subtraction that happens twice. The first thing I said was leave the first number alone. We're going to leave negative 7 alone because that's the first number in the problem and you can't change what you start with. So rewrite that. Here's subtraction. I need to change my subtraction to addition. And we're supposed to change the sign of the number that follows the subtraction sign. So negative 12 is going to become a positive 12. Now there's subtraction again. I'm going to change this subtraction to addition. And now I need to change the number that follows that. So anytime you change a subtraction problem to an addition problem, you change the sign of the number that follows. So this 14 is now a negative 14. Okay, and working with this problem here, it's all addition, and now we're kind of back to the end of the notes from section 1-2. In this one, instead of going from left to right, I see that those would make a nice small number for me, so I'm going to use the associative property and group those first. You can add them in whatever order you want because it's all addition now. But I'm going to leave this negative 7 here, and I know 12 plus negative 14, I subtract the digits and take the sign of the greater. I'm left with a negative 7 plus a negative 2. When you add two negatives, add the digits normally, and your answer is negative. So that one's done. All right, move over to the next one. I have negative 9 minus 16 minus 8. Leave the first number alone. When you change subtraction to addition, change the sign of the number that follows. So this was a positive 16, make it a negative 16. Here's another subtraction sign. I'm going to make it addition, and I need to change the sign of the number that follows it. So that was a positive 8. I'm going to make it a negative 8. So here, I am adding all negatives. So that means all I need to do is add all these digits and keep the sign. So I'll just go from left to right on this one. Why not? When you take a negative 9 plus a negative 16, add the digits. So 16 plus 9 is 25. Keep your sign. And I still have to add that negative 8. Same sign, so add the digits. 25 plus 8. When you have to add by 8, what I would do is add 10 and take 2 away, so I can do it mentally quite easily. So 25 plus 10 is 35. 8's 2 less than 10, so that would be 33 for my digit. And a negative plus a negative is a negative. All right, moving along. Keep change. Leave your 13 alone. Change this subtraction to addition. Change this positive 18 to a negative 18. There's more subtraction, but wait, there's more. Change it to addition. And that was a negative 18, so I'm going to make it a positive 18. So again, we're changing the signs of the number that follow the subtraction sign, leaving that first number alone. With this one, I would use associative again. I would group the negative 18 and positive 18 together because those are additive inverses. They cancel out. So I'm really left with 13 plus 0, which is just a plain old 13. So nice. All right, last one. Excuse me. Keep 0. Change subtraction to addition. That was a positive 9. I'm going to make it a negative 9. I need to change this subtraction to addition. And now I need to change the sign of the number that follows that. That was a negative 5. Make it a positive 5. With this one, I see plus 0. I'm kind of just going to disregard that. What I really need to do is negative 9 plus 5, because adding nothing to something doesn't change it. So two different signs, subtract the digits, take the sign of the greater. All right, one last little thing. In these, it was all subtraction, so you got used to changing all the signs. If you see addition, please remember that you don't need to change that. Addition stays the same. You can use the associative and commutative properties for it. We want it to stay the same. So I ask you to evaluate each of these. That just means solve it. Tell me what it equals. Evaluate and solve. Same thing. In this problem, I see there's subtraction. And I know with subtraction, the number in front of the subtraction sign stays the same right there. Like, keep that, right? Keep what you start with. Subtraction changes to addition. And this negative 2 becomes positive 2. But do you see how this already says plus 14? I'm not going to change that. It's already addition. So you just bring it down. Only change the subtraction to addition and the number that follows the subtraction sign. The just single number that follows it. You don't need to change addition. So now add them in any order that you want. 11 plus 2, that's like back in the day, just normal. It's 13, and I still have to add that 14, and 13 plus 14 is 27. One more of these and then you can be done. Yay! All right, I have 12 to start. You can't change what you start with. This is subtraction. I'm going to rewrite it as addition. I only change the sign of the number that follows the subtraction sign we just changed. That was a positive 16. Make it a negative 16. And this plus negative 8, don't change that. It's already addition. You're only changing subtraction. In this one, I actually would just do it from left to right. So if you wanted to add the 12 and the negative 8 first, you could. If you wanted to add the negative 16 and the negative 8 first, you could. It doesn't really matter. But I'm going to add 12 plus negative 16. I'm going to subtract the digits and take the sign of the greater. Right? 12 plus negative 16, subtract. So 16 minus 12 is 4. I have more negatives than positives. Then I want to add a negative 8 to that. When you have two negatives that you're adding, you add the digits normally and keep the sign. And now you are done. We'll see you tomorrow.